still there. The image that you have there, first of all, I'm an archaeometallurgist by training. Seeing as there is no work in that area, it is so unbelievably niche. I actually do archaeomaterials now, so I look at glass. And the majority of the materials I look at is post-medieval glass from glassworks. But luckily enough, I'm able to come back into what I love through my PhD at York. This is a really beautiful example of a late Saxon weld line, which is something that I've studied for a long time. But again, this is destructive method. What we're talking about today is X-ray fluorescence, the non-destructive method, which most people prefer to use for metalwork nowadays. The difficulty is that to really understand metal, you have to cut it up. And as we all know, people don't like you cutting up their stuff. In terms of technology, there are two options. This option here runs on nitrogen. It has liquid nitrogen that you pour into it to make sure that it stays cool. And most of the time, it gives fairly good bulk data. Again, you have to use maybe 5, maybe 6 analyses across the piece of material that you're looking at, and then have a mean average. The portable I've never been keen on. It's very good for glass. Most of them have no vacuum, and therefore they can't look at the trace elements. But again, it's proved a useful tool. It's something that I'm going to spend the next 3-4 months working with at Fort Cumberland, where I'm doing all my analysis for my PhD. So I may like it after all, but I'm not sure. So what is XRF good for? Absolutely some things. So glass, metal, and ceramics. I say vitrified ceramics, but a lot of the material that I see tends to be of glass, and that works really well because it's homogeneous material. So you can pick up trace elements quite easily. You can pick up things like the wood ash from medieval glass. I've got an example here, which is looking at a set of medieval glass hanging lamps, which were found from the glassworks, from the glass collections from Revo. And when we looked at them, we were actually able to provenance the material in terms of where were these constructed. Material at this period, glass, came from either the Weald or it came from Staffordshire. It seems Staffordshire glassworks were the glaziers for Fountains Abbey. But for these, it seems that they too came from Staffordshire. One of the awful problems here, as you can see from that on there at the bottom, you have this weathering and you have lamination. The top one, again, you have patination. And that's the hard part to work through. So with these, yes, I was able to analyse them, but I ended up cutting pieces out and putting them in coal setting resin and working it that way. So again, there are lots of difficulties. The technique is great for surface applications, for looking at tinning, for looking at gilding, and of course, enamelling. I think with the cabinet version, you're able to use it on vacuum. So therefore, you're able to get your trace elements. But the difficulty is it depends on the material that you have. So we had some beautiful beads from Constantinople. I think they were Viking beads. And they were put in an XRF and somebody put vacuum on. And there was and those beads came out a very beautiful milky colour. So you have to be careful. As a metallurgist, first and foremost, the best data that you get comes from sectioning material. This image I love because it's a Viking knife. You have high carbon steel here, you have a phosphoric knife back, and you have an accordion weld. So they were superb at their welding, which is one of their top skills. And this is basically a piece of metal that has not only been worked back and front, but on both sides. So that's given that beautiful, beautiful accordion structure. In terms of materials, the difficulty is with corrosion in particular. Because XRF only penetrates between 10 to 30 microns, you do get very much surface. Corrosion on these products can be anything up to 100 microns. So you have to find an area on the example that you can clean, but without affecting the surface. So it's quite a complicated thing to do, because that's going to change the chemistry that comes up. Alternatives. Optical microscopy. I mean, again, you're going to have to sample and look under a microscope, but it's easy, it's reasonably cost-effective. X-raying iron objects is fantastic because you're going to see your weld lines. Metallography, there are so few of us who actually do metallography nowadays. It's a dying art. And it's something that I'd love to see reintroduced to scientific courses. But again, it's something that's very much for research. It's not something that you would do for larger commercial projects, which is what I work on most of the time. The thing I love more than anything else, scanning electron microscopy. I spent 6 months with one and was totally spoilt and went to it for every type of analysis. Glass, the whole lot, totally gilding the lily, but it works really well. ICP-MS, again, that's great for materials, but again, we're talking about destruction. So what do we have? We have XRF for the moment. Where I try and focus most of my work is looking at production waste. Production waste gives you the most information about an object. If you can tie production waste to an object, that's fantastic. But if you can tie it to a site, that's just as good. You'll get the raw materials before they've been manipulated by heat. So my focus is very much on that. Crucible evidence I absolutely adore, but the interaction between crucible and material affects the composition. Iron is one of the most wonderful metals. It is so complex, it's so complicated, and it spends its whole life trying to return to its oxide. It's a terribly romantic metal. I have a very soft spot for it. But again, people look at the iron slag and they say, how fantastic is this? We brought you some slag. Well, from the Roman period right through to 14th century, that slag could have come from anywhere unless you can tie it to a furnace. So it's something that I tend to leave to those who are really slag orientated. And where are we now for the 11th and 12th century? I found this rather disappointing. It's not a period that I know very well. I tend to kind of kick in around 14th century, then go into post-medieval, or I'm Roman, late antique, and a little bit of Viking. So this was something quite new to me. And it's because we don't have the materials. There are very few analyses for this period, and I'm really surprised. I thought it was just me being, not very competent, so I went and asked the powers that be, and no, there aren't that many examples. So it's definitely a niche, another niche, that we could expand upon. So, XRF is fantastic. It has its pluses and it has its minuses. You can bring it on site if you need to look at something quickly and cost efficiently. But at the end of the day, I don't think it gives enough information. I think we can get information in other ways. I think the problems that we have is that a lot of the metallurgy is not securely dated. And therefore, to look at sites where we have production waste is probably the best way of seeing what is being used. And that's it. Thank you.